All right, sixth graders, today we are talking about equivalent fractions. So I want you to know the definition of that. Fractions that represent, so they show or have the same value are equivalent fractions. So you can see right in the word equivalent that equal, right? So you could have 1/2 of something, but that, if your spaces were the same, you could also separate that into 4 pieces, so that would equal 2/4. And continuing on from that, you could also have 4/8. But do you see how they all represent the same thing? They're all equal. They are equivalent fractions. So here's what's important for you to know as you are creating equivalent fractions. To create equivalent fractions, multiply the numerator, that's the top number, remember, and denominator, the bottom number, by the same value. So if I told you to list 2 equivalent fractions, and you had 3/4, so you want to know 2 that they're equal to. Well, what multiples do you know? You're probably pretty good at multiplying by 2, right? Just doubling. So I'm going to multiply the numerator and the denominator by the same value. We can do that because that's just like multiplying it by 1. And it does not change its identity when we multiply something by 1, right? 3 times 1 is 3. 279 times 1 is just 279. So this does not change its identity. 3 times 2 is 6. 4 times 2 is 8. So there's one equivalent fraction of 3/4. What else could we multiply by? 3 or 5 or even 10 might be easy if you're good at your tens. So 3 times 10 is 30. 4 times 10 is 40. The point is, it doesn't matter what you multiply it by as long as you're doing it by the same on the top and the bottom. So I want you to try, pause your video and try 4/5. Okay, so I probably would always stick with 2/2, multiplying the top and the bottom by the same number. You have 8/10. And for one more equivalent fraction, maybe multiply by 5 this time. So you have 20/25. Do you see that we had been practicing simplifying from here or here down to the most simplified form, and now we're practicing writing 2 equivalent fractions? So you may also see things like 1/2 is equal to what over 6? So here you're asking yourself, okay, what did I multiply the 2 by to get the 6? You said 3, you're right. So whatever you do to the bottom, that's what you would have to do to the top. So 1 times 3 would be 3. Does that make sense? Let's practice a few more of these with the things in the, with the one of them already decided for you, because you do have to do some checking. Well, this one's a little tricky. Now, instead of multiplying here, we divided, right? So what did they divide the 15 by to get a 3? 3 times what is 15? 3 times 5 is 15. So we also have to divide the bottom by the same thing. So 20 divided by 5 is 4, because 4 times 5 is 20. Alright, I'm going to give you 2 more of these. Well, let's just do 3 more of these. It's good practice for you. So let's go with 3 over something equals 12 over 40, and something over 40 equals 2 over 5. And 7 over 3 equals 42 over something. So you can see that's an improper fraction, alright? 3 times what is 12? Make sure you're pausing this and trying it on your own. So that means I have to divide this by 4. I'm kind of going backwards. I shouldn't show it like that. So if I divided the 12 by 4, I have to divide the 40 by 4. 5 times what is 40? 5 times 8 is 40, right? 2 times 8 would be 16. Remember, you're figuring out what you did to one and then doing the same to the other. Because whatever you do to the top, you have to do to the bottom, or whatever you do to the bottom, you have to do to the top. So it's like being multiplied or divided by 1, which does not change its identity. It keeps it equal to or equivalent. 7 times 6 is 42, so 3 times 6 would be 18. Alright, hopefully that was good practice for you. So I want you to remember, if they are equivalent, so you will see a list of a couple things. So 8 twelfths, comma, 4 sixths. Would you say those are equivalent? Well, 8 divided by 2 is 4, so 12 divided by 2 is 6, so I would say yes, they are equivalent. How about 1/4 and 4/20? Well, 1 times 4 would equal 4, so 4 times 4 would not be 20, so this would be a big fat no, right? So make sure you're understanding that you're checking to see what was done to one and then checking it with the other to make sure the exact same thing was done to it. So 6/18 and 5/15. I would say no. How would you get from 6 to 5 by multiplying or dividing? Well, you couldn't, so that's a big no. So remember, these would be like fractions, and these would be unlike fractions, right? I know that is a lot, you guys. But remember, whatever you do to the top, you have to do to the bottom. And then when you are determining like the missing top or bottom, you're figuring what was done to one. How would you multiply or divide one or the other to get it, and then doing the same thing to the other. Same with when you're checking if they're like or unlike. You want to make sure that whatever was done to one, or even if something could be done to one through multiplication or division, to change it to the other. All right. Don't forget to be showing your work and including an image of that if necessary. I want to see like what you're multiplying by here. Like I showed these steps. If I'm showing the steps, remember you should be too. All right. Have a wonderful Monday.